Boyle's Law. Introduction. Boyle's law was put forward, by the Anglo-Irish chemist Robert Boyle in the year 1662. Boyle's law, also called Marriott's law. Statement of Boyle's law. Boyle's law is a gas law which states that the pressure exerted by a given mass of a gas at a constant temperature is inversely proportional to the volume occupied by it. In other words, the pressure and volume of a gas are inversely proportional to each other as long as the temperature and the quantity of gas are kept constant. For a gas, the relationship between volume and pressure at constant mass and temperature can be expressed mathematically as follows. Pressure P is inversely proportional to the volume V, where P is the pressure exerted by the gas and V is the volume occupied by it. Now, we can put constant K in equation 1. The proportionality of equation 1 can be converted into an equation by adding a constant K. Now pressure P is equal to K into 1 by volume V. Or, PV is equal to K. The pressure versus volume curve for a fixed amount of gas kept at constant temperature is illustrated below. It can be observed that a straight line is obtained when the pressure exerted by the gas P is taken on the y-axis and the inverse of the volume occupied by the gas 1 by V is taken on the x-axis. Boyle's law explains the relationship between the pressure and volume of a perfect gas. It states that the volume of a perfect gas is inversely proportional to the absolute pressure, where provided temperature and the amount of gas remains constant. Here, we can see this in figure clearly. The figure also explains that if the volume is decreased, the particles of gas hit the container much more frequently, thereby increasing the pressure. Similarly, on increasing the volume, the pressure is reduced. We can see this in figure clearly. According to Boyle's law, for a fixed amount of gas kept at a constant temperature, PV is equal to K. Let us consider P1V1 is the initial pressure and the initial volume of a gas and P2V2 is its final pressure and final volume at constant temperature and number of moles. Then we can get following relations. P1V1 is equal to K. Here, P1V1 is the initial pressure into initial volume, and K is the constant. P2V2 is equal to also K. Here, P2V2 is the final pressure into final volume. Here in equation, P1 is the initial pressure exerted by the gas. V1 is the initial volume occupied by the gas. P2 is the final pressure exerted by the gas. V2 is the final volume occupied by the gas. By using equation 3 and 4 we get the following relation. P1V1 is equal to P2V2. This is the required equation of Boyle's law. This equation can be used to predict the increase in the pressure exerted by a gas on the walls of its container when the volume of its container is decreased and when its quantity and absolute temperature remain unchanged. Significance of Boyle's law. Boyle's law proves mathematically that gases are compressible. Greater the compression, more is the density and hence, greater will be its pressure. It shows the relation between pressure and density of gas. At constant temperature, pressure P proportional to density D. At high altitude gases pressure is low, the density of gas is also low. This results the less availability of oxygen for breathing at high altitude. Due to this reason, mountaineers have to carry oxygen cylinders for breathing purpose. Boyle's law shows how volume of given mass of gaseous substance varies with pressure.